All right, let's do a little bit of graphing here using the idea of rate of change. Every 3 seconds, 4 cubic feet of water pass over a dam. We're going to draw a graph of the situation and we're going to find the unit relationship of this proportional relationship. So proportional relationship means a couple of things. It means the rate of change is constant and it means it passes through the point 0, 0. So those two things in mind, constant rate of change passes through 0, 0. Let's go ahead and graph this. So in order to graph it, I think the very first thing we should do, step number one, is to make a table. So step one, let's make a table. Step one, make a table. That's a little bit thin. Let me get a little thicker pen there. Okay, so what are the two things that we're measuring here? Well, it tells us right at the beginning every 3 seconds and then 4 cubic feet. So the two things that we're measuring are seconds and cubic feet. So that's going to be the two things in my table, seconds and cubic feet. And the input here is going to be time. As time passes, more water goes over the dam. So I'm going to make time my x variable, time in seconds. So I'm going to put time at the top of my table. And then the volume, which is what cubic feet is measuring, volume is going to be my y variable. So that'll go on the bottom, volume. And the way that you write cubic feet as a unit is you just do feet with a little 3 there for cubic feet. Now that doesn't mean that the numbers we put here are going to be raised to the third power. That's not what that cube means. It's just cubic feet as a unit. So we're not going to change the numbers in any way. That's just how we write the unit. Okay. So let's go ahead and fill in the table. And it says every 3 seconds, 4 cubic feet of water pass over a dam. So I'm just going to make this as easy as possible. And I'm going to say, well, that means after 3 seconds, 4 feet of water have passed. And I'm not even going to try to do like what happens after 4 seconds, 5 seconds, etc. I'm just going to say, well, 3 seconds after that. So after 6 seconds, that means 4 more feet have gone. So that'd be 8 altogether, right? And then 3 seconds after that would be 9. So 4 more feet would be a total of 12. And I don't really know how many we should do. You know what? Let's just do that many because that's how long I drew the table. So 3 more seconds later would be 12 seconds and 15 cubic feet. And then 3 seconds after that would be 15 seconds. Oh, already made a mistake. Did you know that 12 plus 4 is not 15? 12 plus 4 is 16. And then 16 plus 4 is 20. All right, there we go. So now we've got a table with our time and our volume. So that was step number one, was to make a table. Why was that step number one? Why did we need a table? Well, because we are going to graph this and I need some points if I'm going to graph it. Okay, so I'm going to come down here and make a graph, and I really need a good graph because I'm going to try to find the rate of change from the graph if I can. So I'm going to use a ruler to make the graph. Now, the graph needs to be big enough on the x-axis to go all the way up to 15. So on the x-axis, I'm going to go, let's see, maybe if I go by 2's on the x-axis. So let's see if I just see how many lines I'm going to need. If I go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's way more than I need, up to 20. That's fine. And I'm going to need to do the same thing on the y-axis. That's also going to need to go up to 20. Let's see if I can squeeze that in here. So let me go ahead and draw the y-axis. I'm using the half-inch markers on my ruler to do these so that they're all equidistant. So 2, 4, 6, 8, 10, 12, 16, 18, 20. Oh yeah, easy. Okay, so my x-axis is scaled out in such a way where I'm going like 2, 4, 6, 8, 10, 12, 14, 16. I could have stopped at 16, I guess, but we did a little extra. That's okay. And then the y-axis I made a little more compact. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I made the y-axis a little more compact just because I didn't leave enough space after the table to draw a longer y-axis. So let's go ahead and clean this up a little bit. We used a ruler to make it look nice. Might as well shorten the axes there. Okay, great. So now we're going to go ahead and put our points on there. So our first point that we have is 3, 4. So I'm going to do my best to get 3, 4 in the right spot. So an x coordinate of 3 is going to be in between the 2 and the 4. So 3, 4 looks pretty good for a spot for 3, 4. And then next is 6, 8. So I like 6, 8 about right there. Looks pretty good. Now if I'm doing this right, when I'm finished, these points should make a line because a proportional relationship has a constant rate of change, and a constant rate of change should make a linear graph. So hopefully, let's see, 9, 12 is our next point. 9, 12 about right there. Hopefully this graph should look as close to linear as I can get without doing a grid on here. 12, 16 is about right there, and then 15, 20 should be, so the 15's in between 14 and 16, and they'll go up to 20. I don't know if that's perfectly straight. Let's connect the dots if we can and find out how close to straight we got. Well, that's not perfect, but that's pretty darn close. I think we can live with that. That's pretty good. Does it go through? It doesn't quite go through 0, 0 like it's supposed to, but you know what? That's pretty darn close. I didn't quite make it through 0, 0. You know what? I'm gonna try again. Because it is supposed to go through 0, 0 if it's a proportional relationship. So let me try again here. I think we can do a little better. Let's try that. Is that better? There we go. That is not half bad for eyeballing it. That's pretty good. I'm proud of that one. I'm gonna print that out and put it on the fridge. All right, there we go. So there is our line. So there's our graph, which was the first thing that we were asked. But the second thing that we were asked was to find the rate of change. So finding the rate of change, one of the ways that we can do it is by counting the rise over run, which was one of the reasons we wanted to make such an accurate graph. So let's use, you know what, I want to use some of these points that I was a little more sure of. And those are the ones where we didn't put the points in between two x values. Like for example, our point 3, 4, I was kind of estimating that 3 was in between the 2 and the 4, but then the point 6, 8, like we had a coordinate for 6. So I like 6, 8 as a point because I could put it right on 6. You know what I mean? And I like 12, 16 also. 12, 16, because that one we could put right on 12. So I like those 2 points. So let's see if we can figure out what the rise over run would be between 12 and 16. So remember, the rise is the y coordinates. So if my y coordinate here is 8, and I'm counting up to 16, and some of you, I can tell, are already doing the math rather than trying to count. If I'm at the 8, and I count 8, and I'll go 9, 10, 11, 12, 13, 14, 15, 16, how much do I count up to get to the 16? The answer is 8. And then the x coordinates, that would be this 6 right here and this 12 right here. So if I'm at 6 and I'm counting over to 12, it goes 6, 7, 8, 9, 10, 11, 12. How many times did I count over? 6. So my rise over run would be 8 over 6, which reduces to 4/3. So my rate of change, so the rate of change is, and it's 4/3, but 4/3 what? What were we measuring? Well, our units were cubic feet and seconds. So 4/3 cubic feet per second, or if we really wanted to shorten this down, we could say 4/3 and then do cubic feet, our feet with the cube symbol, per second. 4/3 cubic feet per second would be another way that we could write that rate of change. So every 3 seconds, 4 cubic feet go over the dam. That's 4/3 cubic feet per second. Now, before we end here, I want to go back and look at the table. 4/3 cubic feet per second. And right here, right at the beginning, we had the point 34. We had the point 34, and then our rate of change ended up being 4/3. I wonder if that's a coincidence or if that's going to turn out to be important later.